Hey guys, so this video is going to provide some additional practice problems using the angle addition postulate. Feel free to pick up a worksheet from the classroom that has these examples as we go through them right now, or you can copy them down to your notebook. So we have three examples. This first one we're going to look at involves three different angles here. So we have angle AEB right here, angle BEC, and angle CED. And obviously there's some additional information given here. I highly recommend in all of these problems that you take a couple colored pencils, a couple markers, a couple colored pens, whatever it may be, to help you kind of highlight some of these different angles so that you can look for relationships a lot easier. So for example, AEB is listed as x plus 8. So I'm going to go ahead, instead of writing all that out, I'm just going to go ahead and use my red pen to mark that off so I can see the difference. Now the next thing they give me is CED. So CED actually is this portion down here, so I'm going to use the blue pen to recognize that. BEC is next, so that's going to be this one right here in green. And then last but not least, and I'll use a pink highlighter for this, we have AED, which is 67. Now AED is actually going to be all three angles combined. So we have that, okay? So we're basically trying to figure out, well, can I create an equation relating some of these different colors to each other? And so what we should recognize here is this red angle, this green angle, notice the colors over here, the red angle, the green angle, and the blue angle, all three of them when added together has to equal this pink angle since the pink angle represents these three. So I'm going to be able to say 67, which is my pink angle, so I'm going to underline these colors so you can see the relationships. And that's going to actually be equal to, I'm going to change the 67 into black just so we don't confuse it. So 67 is going to be equal to the red angle, so that's x plus 8. It's also going to be the green angle, which is 4x minus 3. And lastly, the blue angle, which we have described as 22. So take a look at that for a moment. We have our pink angle, which is AED, all three of them, is equal to the red, the blue, and the green. Red, blue, green. So now we have an equation, and that's really the geometry part of this problem. From here on out, the rest of this now is just solving this algebraic problem. Creating the equation seems to be the trickiest part of this. So now when we solve this, we're just going to combine like terms. So that's going to create 5x. I have 8 plus 22, which is 30, minus 3 gives me positive 27. Now we're going to solve this. So 67 minus 27 on both sides is going to give me 40 equals 5x, which gives me then x value having to be 8 here. So that's going to be our x value for this problem, and we can fill that in. Now it's going to ask us to find AEC. Well, A, E, and C is just going to be the red angle and the green angle combined. So you can substitute them in, but there is a quicker way. If I know the pink angle is all three of these, and the blue angle is the part that's not AEC, I actually can just subtract these two. 67 minus 22, and that's actually going to give me the angle, which would end up being 45. Now, if you still aren't sure that it's 45, do it the long way, because we know that angle AEB plus angle BEC is also going to give me that solution. So we would then plug the 8 in, so it'd be 8 plus 8, and then BEC would be 4 times 8 minus 3. Well, 8 times 8 is 16. 4 times 8 is 32, and minus 3. Well, 16 plus 32 is 48, and 48 minus 3 is 45. So either way, we end up with 45 as our solution. And BEC, while we're talking about it, we already figured it out technically. It's just going to be 32 minus 3, so that's going to end up being 29 for our first problem. In our second problem here, these are going to be not algebraic in nature, but we're going to have to look for relationships. So CBD, for example, I'm going to go ahead and use my green highlighter. So it's important that before you start talking about the problem that you create some sort of visual to help you understand what's going on here. And that's exactly what I'm doing. So I'm taking these different color highlighters. So we have DBF. That's actually going to be all these two together. And then the last one I'm out of highlighter, so we'll just use a blue pen. That's going to be ABE, which is going to be these three angles together. Okay? So we basically need to figure out ABF, ABC, and EBF. Now, before you go ahead and pinpoint that, let's talk a little bit about what we know. I know this is 28, and I know this angle is 16. I know that these two yellow angles together have to be 34, which means since you know this is 16, since it was the pink, I can actually figure out this little angle here. Both of these together make 34, as described here. So 34 minus 16 is actually going to give me this missing angle right here. And so when I do that, I end up with 18. Now, mind you, I'm not even looking over at what we have to answer yet. I'm just simply finding each individual angle. Now, going back over to here, this is the last little piece that I need is ABC. Because I know this is 18, this is 16, and this is 28. For this little guy right here, I know that these three angles right here that my pen is pointing to create the blue angle 82. I know this is 16, I know this is 28. So I know that this missing angle has to be whatever is left over of that 82. Mainly, 82 would equal the missing angle plus 28 plus 16. That's what we know. So I just simply have to now subtract the 28 and the 16 from the 82. And so in this case, we end up with a 38-degree measure. Now answering these questions will take 2 seconds. ABF is just adding up all four of these individual angles. So 38 plus 28 plus 16 plus 18. And so when I do that and add them all up, I get a nice even 100 degrees for that. ABC, well, that's this little sliver up here, A to B to C. That's going to end up being 38 degrees. And lastly, EBF was what we found in the beginning. That ends up being 18 degrees here. So it's really important to establish relationships before you start a problem using colored pens, markers, highlighters, or something like that to help you with the problem. And for our last question in this video, we're going to take a look at this. And the most important thing to note is the very first statement that's different. We're saying that BD bisects ABC. Remember that the word bisects means splits in half or two, or, it's an R, two equal parts. I'm going to move my hand so you can see. So bisect means splits in half or two equal parts. So BD, which is this segment right here, I'm going to use my green highlighter to mark, is cutting angle ABC into two equal parts. So we denote that in geometry, but I'll put these two arcs in black, and I'll put these little marks. What it means is that this angle here, which is I guess called ABD, is actually equal to these two angles combined, because this is the other half, DBC. So I have a relationship that this is equal to both of these. Now, let's go ahead and mark what we know. So I know that ABC is listed as 54 degrees. ABC is the entire thing. All three angles combined. And then the other one that we have here, we'll use blue, is DBE. So DBE ends up being 12, which means this little sliver right here ends up being 12. Right off the bat, what we have to recognize is that these black angles, when you add this black angle and this black angle together, they're equal to each other, of course. It's going to equal the entire thing, which means these two angles equal the pink. Since these are equal, that means the 54 degrees has to be split evenly among these two angles. So if I take my 54 and divide it by 2, I'm going to end up getting 27. So 27 represents this angle, and 27, here's the key, represents these two angles. Which means this angle is not 27. If these two angles have to add to 27 to figure out this guy, remember that 27 would then equal 12 plus that missing part that we don't know. So we would just have to do 27 minus 12. So that makes this angle right here 15 degrees. And I believe that's actually what we were looking for. EBC here has to be 15 degrees in our problem. So feel free to go back to these videos, to this video I should say, and watch any of these problems over again if you have any trouble going through any of your classwork or homework problems using the angle addition postulate.